Okay, now we're going to start with, it's still chapter 10, it's still enteral and IV administration of drugs, but this is a different type of problem that I wanted to go over separately. So this is for IV flow rate, and it says the order reads 1,000 milliliters of dextrose 5% in water in an IV over 8 hours. The drop factor is 10 drops per milliliter, and after 5 hours, 700 milliliters remain to be infused. How much of the flow rate is going to be adjusted in drops per minute so that the infusion will finish on time? If the facility has a policy flow rate and adjustments must not exceed 25% of the original rate, is the required adjustment within guidelines? So that's a lot. And then it says, note, when you see the word adjusted, okay, so that shows you how to start preparing for your answer. So what I want you to see is that we're only going to answer the first question. And the first question says, how much the flow rate must be adjusted in drops per minute so the infusion must finish on time. In this note section down here, you see the word adjusted. When you see adjusted, you have to have a start rate. What did it start with? And then what did you adjust it to? So right here, the flow rate, it says in drops per minute. So I'm going to go the flow rate in drops per minute. Originally, let's figure out what that was. So right now we need to find drops in top or time in bottom. Right now we have 1,000 milliliters over 8 hours is one fraction, and 10 drops per milliliter in another one. So I'm going to use 10 drops per milliliter because drops is on top. And then I need minutes on bottom, so I'm going to multiply to get milliliters out. And when I look up here, I'm going to use 1,000 milliliters per 8 hours. So my milliliters went away. However, I need to get it into minutes, so I'm going to keep going and put hours on top. And I know that 1 hour is 60 minutes. So when I cancel out those, I can do my calculations. So I have 10 drops per 1 milliliter, or 10 times 1,000 is 10,000 divided by 480. And I get 20.8. And this is drops per minute. But because it's in drops, remember, drops mean it has to be in a whole number because you can't do a partial drop. So it's going to be 21 drops per minute. So what would the adjusted rate be? Well, what do we need to know? Let's see here. We need to know the drops per milliliter. So drop factor is never going to change. So the drop factor is still 10 drops per milliliter because you didn't change the tubing. You just changed the amount that's in there. And it says after 5 hours. So now this hour down here is not 5 hours because after 5 hours, there's 8 hours. So this would be 8 minus 5. So this would be 3 hours. It says 700 milliliters remain to be infused. So 700 milliliters remain to be infused. Now it could have said 700 milliliters have infused. And if that's the case, we would have had to take the original amount minus the 700 if it have been infused, but it has not been infused. It says 700 milliliters remain. So since they remain, then I'm going to do my adjustment that way. And I still have to get my hours into minutes. So I'm going to, there's for every 1 hour, 60 minutes. And now I can do my calculation. So now it's 7,000 divided by 180. And you get 38.89. Drops per minute. So that's going to be 39 drops per minute. Because remember, you have to have a partial drop. So then that's our answer, is it must be adjusted to 38.89 in order for it to finish on time. So if it wasn't going to finish on time, if it was going to finish in 3 hours, then down here would just automatically be 3 hours. If it said must finish in 5 more hours, then I would have put 5 down there as my time. So really read the question and ask and see what it's asking. So then the next one says that the facility had a policy that flow rate adjustments must not exceed 25% of the original rate is the requirement in the guidelines. So in order to do that, we have to do percent increase or decrease. We have the original, so we have the change in amounts over the original amount, and then we're going to times it by 100. And it says must not be greater than, so less than or equal to 25%. If the adjustment's safe, then you can go ahead and do it. But if it's over 25%, contact the doctor. So here the change would be 39 minus 21 over the original, which was 21, and times 100. And that has to be less than or equal to 25%. So the change, 39 minus 21, is 18 over 21 times 100. It has to be less than or equal to 25%. So 18 over 21 times 100 is 85.7%. And that is not less than or equal to 25%. So contact the doctor. Don't make adjustments. So try this next one. And when you're ready, come on and come back and see what I've got here for an answer as well. All right, so I'm going to start. And it says the order is normal saline, 800 milliliters, and an IV to infuse every 6 hours or in 6 hours right away. When the nurse checks this infusion, 3 hours later, 330 milliliters are left in the bag. Recalculate the pump setting so the infusion will finish in 2 hours. If the facility protocols indicate that the flow rate adjustments must not exceed 20% of the original rate, may the adjustment be made. Well, let's see. So this says recalculate the pump setting so the infusion will finish in 2 hours. So I know that my original amount, so recalculate told me this. I know it said adjusted, but recalculate works also. The original amount, and since it doesn't say in drops per minute, I'm just going to leave it in milliliters per hour. So the original amount was 800 milliliters to be infused in 6 hours. So 800 divided by 6 is going to be 133 milliliters per hour. The adjusted would be well, the nurse checks the infusion 3 hours later, so that would be 6 minus 3 hours would be 3 hours. It says that there are 330 milliliters left in the bag. So again, this tells you that there are 330 milliliters left here. If it says have drained or have gone away, then I would have subtracted that from the 800. But it says that's how much is left in the bag. So I want to know now what my adjustment will be. So 330 divided by 3 would be to 110 milliliters per hour. So the adjustment would be 110 milliliters per hour. And then now the flow rates must not exceed 20%. So if I do 133 minus 110 divided by the original amount has times 100, it has to be less than or equal to 20%. So when I do it, I do 133 minus 110 equals 23 divided by 133, and it's just 17%. So it's 17%. So then it's okay. Make adjustments. Awesome sauce. So, cool. So what's this? Fluid intake and output. So I got this right from the book, so I'm going to read it to you because it explains this better than I could, for sure. And it says the fluid intake or output. To work well, the various body systems need a stable environment in which their tissues and cells can function properly. For example, the body requires somewhat constant levels of temperature, salts, glucose, and in particular, adequate hydration to maintain homeostasis. Part of hydration management involves the monitoring of a patient's fluid intake and output. This is especially important with pediatric, geriatric, and critical care patients. So fluid intake is the amount of fluid that enters the body, oral and parenteral fluids, while fluid output is the amount of fluid that leaves the body through urine, sweat, liquid stool, emesis, throw up is what it means, and drainage. Fluid replacement is sometimes necessary to avoid dehydration. If a physician provides an order with a specific ratio comparing the necessary replacement fluids with the patient's fluid output, and if the patient's fluid output is unknown, then dimensional analysis can be used to determine the volume of replacement to give the patient. So there are two ways to do this. There's an easy way and there's a math way, which you probably won't find as easy, but it'll work every time. So this says for every 100 milliliters of urine output, replace with 40 milliliters of water via the PEG tube. So if the patient's urine output is 300 milliliters, what is the replacement volume? Well, here, if we have for every 100 milliliters of output, we replace it with 40 milliliters replaced, so it's input. So I have 100 milliliters output with every 40 milliliters replace. So then it says the patient's urine output is 300 milliliters. So 300 milliliters is the output. And I need to know the replacement volume. So my answer has to have replacement on top. So I have to flip these around so the out is over here. So I have 100 milliliters out with 40 milliliters to replace. So when you do that, my outs cancel. And when I'm left, I have milliliters replaced. The reason why I said out and replace, because if I didn't, it would have milliliters over milliliters, and you would think they were the same thing for dimensional analysis, and you might have just canceled them and had no units left. But now when I do this, I do 300 times 40, and then divide it by 100, and I will get 120 milliliters. Replace. So that's using dimensional analysis. If I don't want to use dimensional analysis, you can make yourself a chart and you can have hours, in, put, out, input. So for the hours, the first hour, second hour, the input, it says for every 100 milliliters, replace with 40. You don't need hours on this one. So for every 100 milliliters out, you place with 440 milliliters in. You don't have hours on this, my bad. I memorized the wrong question. So then if 80 milliliters, you need 80 milliliters in if 200 milliliters were out, because another 100 milliliters. So if you would go further, then for every 300 milliliters out, it would be another plus 40. So 8 plus 4 is 12, so 120 milliliters in. And then it asks you 300, how much? And you would say 120. That's non-mathematically. What's this happened? This says, I thought you said the chemical composition for water was H2O, H-I-J-K-L-M-N-O. And that's me telling you, no, it's H2O, H2O. And you're like, yeah, H2O. And so that's why we sometimes get confused with each other while we're talking, because saying one thing and interpreting it is a whole different thing. So let's work together, figure out how we're going to do this, and it's good stuff. Good luck. Yay.